We live in just, well, a flood of data, don't we? Numbers, charts, percentages. It's absolutely everywhere.
Hmm.
And it's so easy to just glance at something, and think you've got the whole story.
Yeah. But often what you're seeing is just one particular slice, maybe even a carefully chosen one.
Exactly. That's the real challenge, isn't it?
Yeah.
We're kind of wired to look for quick answers and statistics. They can seem so definite.
Hmm.
Uh-huh.
But without digging a little deeper, like you said, we can easily misunderstand what's being presented. Sometimes it's intentional, sometimes not.
Right. And that's precisely why we're doing this deep dive today. We're looking at some really vital ideas, drawing from Jane's excellent summary of Darrell Huff's classic, How to Lie with Statistics.
A foundational book, really.
Absolutely. Think of this as like your essential toolkit for becoming a sharper, more informed reader of data.
Hmm.
Our mission is pretty straightforward: to pull out those key lessons from Jane's breakdown that you can use, right away, to make sense of the numbers you see every day. And importantly, avoid getting a skewed perspective.
And these skills are just so necessary now. Being able to critically look at statistical claims isn't just for, like, data scientists. It's fundamental for anyone trying to understand what's really going on.
Couldn't agree more. Jane's piece is a fantastic entry point into Huff's thinking, which is still so relevant.
So where do we start?
Okay, let's kick off with something we all see constantly:
Mm.
graphs.
Hmm.
Jane's first lesson is spot on. We need to be really careful when reading them.
Hmm. Visuals can be powerful.
Yeah, and powerfully misleading. He uses this great example: a B2B e-commerce app looking at its average order value over 16 weeks.
Okay.
So a reporter looks at the first graph and summarizes it as trending constantly. This is pretty flat, right? Stable.
Sounds straightforward. No big changes.
But here's the kicker. Jane shows the exact same data, but just tweaks the graph. Specifically, the y-axis, the vertical one,
Oh.
changes the scale.
Ah, the classic axis trick.
And wow, what a difference. Suddenly, that flat line, it's gone. Instead, you see a clear upward trend in the average order value.
So it wasn't constant.
Not at all. And what's more, this pattern emerges a dip and then a jump every 4 weeks, a kind of fourth-week seasonality that was completely hidden before.
Totally invisible in the first graph.
Totally. Same numbers, completely different story depending on how you frame it visually.
That really highlights it, doesn't it? How much impact the visualization choices have. Just by stretching or squashing that y-axis range, you can make small changes look huge or, like in this case, make real trends disappear.
So the big takeaway here for you, the listener, is don't just glance at the shape of the line. You've got to zero in on those axes.
Where do they start? What are the intervals? Is it starting from zero or somewhere else to exaggerate things?
Exactly. Don't just take that first visual impression as gospel.
Yeah.
And Jane makes another great point. If you can, try to see the actual raw data behind the graph.
Yeah, the numbers themselves, that's often where the real story is, without the visual spin.
Okay, moving on. Lesson number 2 from Jane. Always check the sample size.
Oh, this one's fundamental. It's easy to forget, but so crucial before you draw any big conclusions from data.
It just makes sense, right?
Yeah.
If you want to know about a whole group, asking, say, 5 people
Mhm.
isn't going to tell you as much as asking 500.
Precisely. The larger the sample, generally speaking, the more reliable your conclusions are likely to be. There's less room for random chance to skew the results.
Jane uses a really simple, clear example for this: coin flips.
Right. Imagine you flip a coin 10 times and get 7 heads. That's 70%. Might make you wonder if the coin's biased.
Yeah, a bit suspicious maybe. But now picture flipping it 100 times and getting 70 heads. Still 70%.
But that feels much stronger, doesn't it? Getting 70 out of 100 gives you a much firmer reason to think something's actually up with that coin.
It has more statistical weight, you could say. Less likely to be just a random fluke.
Exactly. That larger sample size gives your findings more power. You're less likely to mistake a random blip for a real pattern.
So while 7 out of 10 heads is, interesting, you probably wouldn't bet the house on the coin being rigged.
Probably not.
But 70 out of 100, that feels way more significant. And Jane connects this perfectly to the real world.
Yeah.
We see it constantly. Big, sweeping statements made based on really small studies or surveys.
And that can be incredibly misleading. A tiny survey might give you some interesting anecdotes, some stories, but it's unlikely to give you a truly reliable picture of what a whole population thinks or does.
So a key question for you to ask whenever you see a claim based on data is, how many people or how much data are we actually talking about here?
Is that sample big enough to really support the conclusion they're drawing? Super important.
Okay, lesson 3. This one's a biggie and a classic source of confusion.
Mm.
Correlation versus causation.
Ah, yes, the mantra. Correlation does not imply causation. Easy to say, harder to remember sometimes.
It really is. So Jane defines correlation simply. It's when two things tend to move together. One goes up, the other tends to go up, or maybe one goes up and the other goes down.
There's a relationship, an association between them.
Right. Causation, though, is different. That means one thing directly causes the other thing to happen. A leads to B.
And this distinction gets blurred all the time. Sometimes accidentally, sometimes maybe not so accidentally.
Jane uses a really common example to illustrate this, the link between education level and income.
Okay, yeah. We generally see that people with more years of education tend to earn higher incomes. There's a positive correlation there.
Right. And it's so tempting, isn't it, to jump straight to, more education causes higher income.
It seems logical on the surface.
But, as Jane points out, it's not necessarily that simple. Yes, education likely plays a role,
Okay.
but is it the only cause? Or even the main one? What about other factors?
Exactly. Things like family background, connections, innate talent, the specific field someone chooses, even just being in the right place at the right time, luck. All these things can influence income too.
So the education and income might move together, but assuming one directly causes the other without considering everything else, that's where you can go wrong.
Yeah, you might oversimplify the situation. Maybe people from wealthier backgrounds are more likely to get higher education and have connections that lead to higher paying jobs. Education isn't the sole driver there.
Assuming causation, when it's just correlation, can lead to really flawed decisions,
Yeah.
maybe focusing policy on the wrong things.
Absolutely. So the critical takeaway. Just because two things happen together or trend together doesn't automatically mean one is making the other happen. Always ask, could something else be causing both? Is it just a coincidence? Be skeptical of easy cause and effect claims.
Okay, lesson number 4. This one's about digging into the numbers behind percentages and averages. These summaries can hide a lot.
They seem neat and tidy, but yeah, the underlying details matter hugely. Let's start with percentages.
Jane gives this brilliant example. Imagine a business reports an 80% increase in sales. Sounds amazing, right?
Fantastic growth. Break out the champagne.
Hold on, though. Jane then asks the crucial question. An 80% increase on what? Was the starting point, say, 3 lakhs rupees in sales? Or was it 3 crore rupees?
Oh, makes a massive difference.
Totally. An 80% jump on 3 lakhs is, what, a 2.4 lakh increase? Good, but maybe not world-changing. An 80% jump on 3 crore is a 2.4 crore increase. That's huge.
The percentage sounds the same, very impressive either way, but the actual context, the base number, completely changes the significance of that growth.
So a huge percentage leap from a tiny base might not mean much overall, while a smaller percentage gain on a massive base could be far more impactful.
So whenever you hear a percentage change, growth, decline, whatever your next thought should be, percentage of what? What was the starting number?
Got it. And the same applies to averages, right?
Yes, absolutely. The average or the mean can be useful, especially if your data is nicely symmetrically distributed, like the classic bell curve. Then the mean gives you a good sense of the center.
But what if the data isn't like that? Jane mentions skewed distributions.
Right. Think about income again. You usually have a lot of people earning around a certain level, and then a smaller number of people earning vastly more.
Those very high earners pull the average up.
Exactly. So the mean income might be much higher than what the typical person actually earns. It's skewed by the outliers.
So in cases like that, the mean isn't really the best representation of typical.
Probably not. As Jane suggests, other measures might be more informative, like the median. That's the exact middle value if you lined everyone up. Half earn more, half earn less. That's often less affected by extreme highs or lows.
Or maybe even looking at percentiles, like the 90th percentile, to understand the top end.
Precisely. The point is, a single average figure, especially the mean, can hide a lot of variation and inequality within the data. You need to understand the shape of the data, the distribution, to know if the average is truly representative.
So don't let a single percentage or average fool you. Ask about the base numbers, ask about the distribution, and look for the context.
Okay, brings us to our fifth and final lesson from Jane. Building confidence in the data source itself. Where did these numbers actually come from?
Yeah, this feels foundational. If the data collection was flawed, then any analysis, any graph, any average based on it is built on shaky ground, right?
Absolutely. Garbage in, garbage out, as they say. So what builds confidence? Jane highlights a few key things.
We already touched on one. Sample size needs to be adequate.
Check. And another crucial one, especially if you're trying to generalize from a sample to a whole population, is randomness. Was the sample selected randomly?
Why is random so important?
Because it helps avoid sampling bias. That's where your sample isn't representative of the larger group because certain types of people were more likely to be included than others. A truly random sample gives everyone in the population an equal chance of being picked, making it more likely to mirror the whole group.
Makes sense. So adequate size, random selection. What else?
How the data was actually gathered, specifically how questions were asked, if it's survey data.
Ah, the potential for leading questions.
Exactly. Jen gives this great example. Imagine a survey asking parents about mobile phone use and grades. One way to ask is, don't you think excessive mobile phone use negatively impacts your child's academic performance?
Ooh, yeah. That question is definitely pushing you towards a yes. It frames phone use negatively right from the start.
Precisely. It suggests the expected answer. This can bias the results because people might agree just because of how the question was worded, not because it reflects their actual belief or experience.
So how could you ask that more neutrally?
Well, as Jane implies, you could take a more open-ended approach, maybe ask something like, what factors, in your view, influence your child's grades? Let the parent bring up mobile phones if they think it's relevant, rather than planting the idea.
Much less biased. It lets the respondent offer their genuine perspective.
Right. So it really boils down to being critical about the methodology. Were the questions neutral? Was the sample truly representative? Were there potential conflicts of interest for the people collecting the data?
If you have doubts about how the data was gathered, you need to view the conclusions with a healthy dose of skepticism, maybe even a large dose.
Okay, so let's quickly recap those 5 key takeaways from Jane's insights on how to lie with statistics.
You'll pull it together. First, be really careful with graphs. Always check those axes and scales.
Second, check the sample size. Is it big enough to support the claims being made?
Third, don't confuse correlation with causation. Just because two things happen together doesn't mean one caused the other.
Fourth, look beneath the surface of percentages and averages. Ask for the base numbers and understand the data's distribution.
And fifth, evaluate the data source. How was it collected? Is there potential bias? Build confidence in the foundation.
These 5 points are like your basic toolkit for navigating the world of numbers more effectively.
They really are powerful tools, aren't they? By keeping these lessons in mind, you, our listener, are just much better equipped. You can spot potential manipulation or just unintentional misinterpretations.
Absolutely. It's not about becoming a statistician overnight. It's about knowing the right questions to ask. It empowers you to demand more context, to dig a bit deeper.
You move from just passively accepting numbers to actively questioning and understanding them.
Which ultimately leads to a much clearer, more informed perspective on, well, pretty much everything.
So here's a final thought to leave you with. Think about a statistic you've encountered recently, maybe something you saw in the news, or a claim made in a meeting, or even just something someone mentioned. Now, mentally run it through these 5 lessons we've discussed. What questions pop into your head? Do you need to know more about the graph's axis, the sample size? Could it be correlation, not causation? What are the raw numbers behind that percentage? Where did the data even come from?
Engaging with stats like that, asking those critical questions, that's the real skill. It pushes you beyond the headline number to seek a richer understanding. And that deeper understanding is key to forming your own well-grounded views.